So we have a whole bunch of clues giving us some hints as to where these things are, but nothing that really would pin them down. What would be really nice, it occurs to me, would be if we could actually work out exactly where these gamma rays are coming from, so we could then point an optical telescope at them and see what it was that was exploding. The trouble is, gamma ray detectors could only tell you very vaguely where things are coming from. The trouble is basically gamma rays go through anything, so it's very hard to have mirrors for them. You look at shadows and you can say, well, it's coming from over there somewhere, but that's not very helpful for pointing an optical telescope. You'd look at an optical telescope there and you'd see 100,000 stars. Which one is responsible, you'd no idea. So what we really needed was some method of pinning down precisely, or at least precisely enough that you could point an optical telescope at it, where these things were coming from.
Yeah, so that was exactly the thing that people were focusing on in the mid-1990s. And it turns out that two groups had this idea. There was a Dutch-Italian consortium, and there was an American consortium. So two satellites were ready for launch, and the Americans went up. It was known as Hetty 1, but its third stage didn't work very well, and so it never really was launched and deployed. So instead, there was the Dutch-Italian satellite known as Beppo-Sachs, shown here just before it went off into space. And so this was a satellite, a gamma ray satellite with a difference. Because on one side, it had this big detector that could detect gamma rays, and it has this lead mask in front of it so you can see the shadows and sort of figure out where things are. But then this telescope on the other side had an X-ray detector, and it turns out X-ray detectors are, you're able to go through and actually image where things are in the sky. You can sort of make mirrors in X-rays, and so you can much better pinpoint where things are. And so in 1997, this object, this satellite was launched, and very soon after being put into orbit, it had its first detection of a gamma ray burst. And here it is.
Okay, so what you can see here is the soft gamma rays and the hard gamma rays. Mind you, a soft gamma ray is still an awful lot of energy. We use soft to mean low energy, but it's actually very high by most people's standards. And there's a big flash, then some more stuff, and it's going on for about 50 seconds or more. Not so much energy at the hard gamma ray, so this is clearly one of the long, soft bursts.
Right, and so we had a long soft burst, and then this telescope didn't move very quickly. It takes like 3 hours to turn it around, and when they turned it around, they saw it in X-rays. And so here is an image taken as soon as they could in X-rays, and about 24 hours later. And you can see this thing had faded. But the difference is, instead of knowing that this is sort of in, many, many, many squares of degrees up in the sky, they knew where this was to about 1/10 of a degree. And so that was enough to put a big optical telescope to look in that direction.
And anyone who was observing around this time would, you'd be at the control room of the telescope and suddenly the phone would ring and there'd be some excitable Italian or Dutch voice at the other end saying, please point to these coordinates. It's only happened to me a few times.
Yes, and I was in the middle of doing all this myself. And when they were able to go through and isolate this object, which they did with the William Herschel telescope, and then they were able to look at it in detail with the Hubble Space Telescope once they had identified it, this is what they saw. They saw a little fuzzy galaxy, and the gamma ray burst occurred on the edge of a distant galaxy at a redshift of 0.7. So that's like 6 billion light years in distance. So, wow.
Wow, I mean, many gamma rays from something that far away, it must be incredibly luminous.
Yeah, so let's go through and calculate exactly what we need to make something this bright.